Okay, I'm going to teach everyone how to make a silicone mask using your 3D printer for about $6. So you can start out with just a simple bucket of water. This is important. You add this soap in, sodium lauryl sulfate, and just put a generous amount. And this is very important for it to not stick to the mold or to your hands. The stuff sticks very, very well. Then you just get one of these tubes. The important thing about these is to be 100% pure silicone, but it has to be silicone clear 1. And this is what I've been using. I haven't done full testing to see if it's skin safe, but one thing is, if you can buy skin safe silicones, but at least you can use this stuff to test your fit and the sizing and everything else. But I think there's a good chance that it'll be safe to use, just as the material for the mask. A couple things: when you buy these cheap caulking guns, they have two pieces of tools on it. One is this little hole here. This little hole here is a cutter to cut this tip off. And it's not the best, but that just cuts a hole in there. Then you flip this pin forward and just poke a bunch of holes in this, so it'll let the silicone out. And you just fold this back under. Okay. Then you put it in this side first. Make sure when these are forward, the way to pull them back is to push this button down and then pull it back. Put it in the butt end first, and then it'll fit. Now you got your bowl of water with your dishwashing liquid. Any kind will really do. You don't need a special dishwashing liquid. For this one, I'm not going to chance it. I'm going to use the whole tube. And we're just squirting this into the water. Now, I've seen people try to do this, use this caulking silicone, but they let it sit in a mold for about 24 hours. Well, the thing is, this is water-activated silicone. So if you mix it in water using the soap, because this stuff will stick to you like crazy, the water activation, when you mix it in, will give you about 45 minutes till it's ready to be mold. But you need to work fast when you do it this way, because you got about 5-10 minutes working time once you get the tube, once you start mixing this stuff. So I'm just going to use the whole tube because I don't want to risk. It's more expensive and more wasteful to come up short of silicone and not get a mask than to use too much. And then I'll show you what you can do with the extra silicone if your mask doesn't need the whole tube. And it usually doesn't, but you want to have too much rather than too little. And you can figure out how empty the tube is by how far this bar has gone. Empty tube, so we're good. Now, just the only way you can't really do this with gloves. You have to do it with your hands. But it's fine. It's silicone. This is food contact safe silicone. And the other thing is, when you use this stuff, it's going to stink like vinegar. But if you let it sit for about a week, or maybe you can air it out faster in the oven or something, you can get rid of that vinegar smell sooner. But you can buy food safe silicone that's platinum cured instead of water cured, and it will cure without having the vinegar smell. Now, one of the things to make it interesting, maybe if you're having trouble getting kids to wear their masks or stuff, is to give it its own personality. So I'm going to pour some glitter in here and give it some color. We could do probably food coloring, anything that's safe. Glitter is usually made safe for kids and stuff. So just mixing a bunch in. You really are on a timer right now. And I'm not going to try to get the glitter all the way through. I kind of like this stretched out marble look. Kind of stirred and stuff. So that's it. With the mold design I've used, you do not need a mold release. But what you do want to do is with your fingers. Okay, that was annoying. The neighbor decided to start using their power tools next door, and I just couldn't match the volume that it was doing. But I didn't want to cut this video short because there's some important parts to point out here. And one of the things is, you see I'm pushing with my fingers. I'm trying to get any air pockets out. I really want to push it in there, especially if you're using one of my molds that has the strap mounts in it, because those have little indentations and stuff, and you really got to push the silicone in there to make sure that there are no air pockets in there or air bubbles. Air pockets and stuff can cause a weak wall, or it can put a hole and it won't be airtight and stuff like that. So it's very important that when you get in there, you really get your fingers in there, and you'll hear some popping and stuff as you squeeze the air out, and just work your way in there. So now I'm just slowly silicone. You can't really force it. You just have to put pressure on it and wait for it to ooze out. And I'm just moving around, letting it, because until the inner mold gets pushed down, it kind of tilts to the side and tilts in all these directions. So you have to keep pushing it until it seats itself, and then it goes flat. And then what you want to do is make sure that the silicone is oozing from all around, so that you know that the silicone has not just come up on one side of the mold, it's come up on all sides. And so I'm just pushing pushing what I call the plug, or the center, or the top piece down. And then what we're going to do is I'm going to what I'm grabbing now is the mold for another piece that I'm going to show you later, because this is a modular mask design, so you can hook up other pieces of 3D printed filters, so you can choose your own filter that you would like to connect if you want a different filter. That's the whole system, or part of the system is to be modular. So I'm filling that plug up right now. Again, I'm going to be pushing my finger in there to clear out the air pockets, and then I'll put the plug in that one. And I'm moving fast because the demold time is about 45 minutes when you mix water in with this water activated silicone. So if the faster you move, the less silicone you'll waste, because all this silicone pouring out of the top of the yellow mold here, you can take that excess and put it into that little seal that I put it in. But also you'll see I'm putting this plate down, and it's an open groove mold that I'm smoothing more of the excess silicone into to make some gaskets. Silicone is a great gasket. It's used in automobiles, so it's a fantastic it's a one-stop thing. You get in the structure of a mask, but you need internal masks to squeeze and sandwich the filters that filter the air, and you do that all with silicone. Same with the other plastic parts that you seal together. Again, you just use silicone. So that's what I'm doing now, and what I'm doing is I'm mushing it into the little groove, and then I'm using a straight edge. You could use like an empty gift card or an old credit card or anything stiff with a straight edge to get a nice flat. You want to skim off the excess on the surface. Otherwise, you'll have a bumpy surface, and that will not form a tight seal. Here we go. Okay, I've had to move my location because when I tried to film the last segment, I was going to do a whole video there. There was too much noise from the neighbors using power tools and stuff, so I had to relocate inside. So I'll go over some of the things I covered really fast, but you should be able to see them in the previous video. The most important thing is that the masks that I've tried to design are, I think, in my opinion, far better than the other designs that people have come up with, or solutions, I should say, for using 3D printers to help make masks to fight Corona. And the thing is that people would 3D print masks, but they're stiff plastic and they're hard to fit, or they use something like some flexibles, but they weren't the greatest for this application. And some people would take the hard mask and plastic and put in here some foam or something like that, but that's not the best either, because then it just creates places for bacteria and stuff to collect. It's hard to sterilize, and you don't necessarily know that it's going to be airtight. So this is actually what I use when I'm printing a mask, or I'm printing a mold for a mask. And what it does is it may not fit my face, but I'll get a really good idea of how well it fits to my shape or my size or my face. And it will get me in the ballpark of when I print a big negative mold for printing a silicone mold. And the thing is, the silicone is much better because of multiple reasons. The silicone is very tough and very durable, but it's also sterilizable. You can sterilize it with Clorox or whatever you want to use, or some kind of antiseptic, but you can also just heat sterilize it. Corona dyes at, I think, don't quote me on it, but 133 degrees Fahrenheit. And this silicone, I think, goes up to 400 without any problem at all. So, and it also makes a great flexible, tight seal on the face. And the thing is, this silicone, the method I showed before, you can make a mask every about 45 minutes, maybe 30 minutes out of a mold. So you can produce a lot more. Some of the methods people were using took overnight and stuff like that. And this is cheap. It's dirt cheap. You can just buy a tube of this silicone 1, 100% pure silicone type 1. And it works great. It's for food contact safe. I don't know if it's, safe for, it's temporary food contact safe, but I don't know for sure. But even if it wasn't the best to use, it's a great way to prototype and get your mask figured out. And then if you want to use some food grade or skin grade or something else, you can do that. So this is a great, cheap, affordable, fast way of making masks that's far more effective, in my opinion, at making sure that everything you breathe in passes through that filter and not around the mask. So it's kind of more of a respirator than it is just a mask. So anyways, earlier we showed how to pour this mold to make it, and it dried up, about solidified, where you could demold it about 30 minutes. And so let's take it apart, and I'll talk more about what's going on here. So I originally tried to make 2-part molds to make it easy on everybody, but 3-part molds just seem to be a lot simpler. Because with the 3-part mold, you don't need any mold release. And the thing is, silicone is great for an airtight seal. So when you print this stuff and you have an airtight seal, it's got such a strong vacuum that it's actually really hard to demold. So this way, when you do a 3-part, it's a lot easier to get the mold apart. One of the things I also did is I 3D printed the bolts so that you wouldn't even have to go and find bolts to do this. So yeah, and people might think, oh, this takes too long to print, but the thing is, how many nights during Corona have you gone to sleep and your printer wasn't doing anything? So it doesn't really matter how long it takes to print the mold, because you're not doing anything with that time anyways. But the part that needs to be fast is the part where this solidifies. It doesn't take 24 hours. And that's done with the caulking, bathroom caulking silicone, when you mix it with water and then dump it in. And then I added some glitter in here to give it some color, so you could individualize each one of yours. So you probably use mica powder or something like that, but it helps to helps you identify which is your mask and not accidentally wear somebody else's. So it's a 3-part mold. Well, I mean, if you don't count the bolts. This one, I had a little clog in my extruder, so the layers were too thin, so this broke, but that normally doesn't happen. This is only, I think, 10% infill, 3 layers top, 3 layers bottom, and 3 layers wall thickness. And it does gangbusters when there's not a clog, and had a little thinning. So anyways, that's the mold. And I'll tell you some tricks about how to, some tricks you can do with the mold. My measurement from the bridge of my nose, from here to there, with my mouth closed, is 124 millimeters. So you can divide that up and scale it and measure yourself from the bridge of your nose to your mouth closed, and get a ballpark of what scale you're going to use for yourself or somebody else you're going to print for. The other nice thing about these molds is that most of the slicers that print 3D molds you could change the scaling. So you could actually make the mold a little skinnier. You have like a narrower face, or you can make it smaller in both the X and Y. And you can just scale it and make it smaller to fit somebody else. The other trick that you can do is you can print this part a little bit smaller than the main part of the mold. Let's see here. Or longer or thinner. So let's say you wanted a thicker wall. Well, you could print this part a little bit shorter, and then you'd have a thicker final mold. Or if you wanted to make the whole thing thicker, you could scale just this part down, and then it would make it a smaller thing, and you'd have thicker walls on the entire mold. So that's a nice feature that you can do. I went ahead and worked with 3 molds because I wanted to make sure that everybody had something that could possibly fit them. And I'll show you some of these molds. One of the molds I did, and I modified from the National Institute of Health. And one of the tricks that I did, what I realized is some people need that nose pinch. So I made these little bumps that you could feed a coat hanger through. This one's too thick and too strong. You actually need a really thin one and a really, but you can now get it to squeeze your nose and fit your face more properly. I also put in these little nubs so that you could put a strap through. And that's great and fine. And I did that with several of these models. Here's another one that I designed. I haven't even cut the flash off yet, but it's got the little strap holes built right in. But rethinking that, I designed the filter, which I'll show you in a minute, to, instead of putting the strap holes on the silicone, you can describe the strap mounts on the plastic itself, and each person can change that to whatever kind of strap they want to use. If they're using like a long, wide ribbon or Velcro, or they just want a little hook, or they want 4 contact points to hold it on the face, or just 2, or anything they want, you can just make a little change to this 3D print, because this is the 3D printed part. This is the part that has to be airtight. And I'll show you where it has to be airtight, because most of it doesn't have to be airtight. But in any case, the print comes out like this. And we're going to just cut the flash off real quick. I'll probably do it faster than normal, so maybe it won't be as clean, but just for, illustration purposes, you can kind of see what it takes to just get the excess silicone off. And the nice thing is this 2-part is only on the outside part, so the inside doesn't have this seam. It's perfectly smooth, so it's not going to have a problem with being airtight on your face. Okay. So let's see here. Okay, and so I think we're pretty good there. I'll just take that out, put it out of the way. But you'll see that you can quickly produce a bunch of masks in a short period of time for a very affordable price. And you have a much better seal, in my opinion, than you will with, your regular disposable fabric mask. So just have to be kind of careful with the razor. And there's special designs that I made for this thing. I made it so that there was a big flare flange, so that the part I'm cutting right now wouldn't ultimately be the part that was in contact with your skin. So it wouldn't have this sharp edge or corner that comes in contact with your skin. So if your face was shaped different, or there's a regular cut to it, it wouldn't leave a hole that would leave you stuck for a tight seal. So that's pretty much it. The only other thing you have to do, and this is the most important part, the most important part is not that I created these masks or created these molds, it's the idea. Okay, and the most important idea is using the silicone as the mask, as the structure, as the shape. And it's sterilizable. But this is the thing. I could have designed it where the hole was already kind of made in, or at least made really thin so you could cut it real quick with a guide. But the thing is that I wanted it to be modular. I wanted it to be able to, if you got something that got a good seal on your face, you could 3D design any component that you wanted to put on here to make this work. And let me give you some examples. Okay, so this piece is one where you could just put your own mask in, and I designed it with some wrenches so you could take it apart. Okay, I'm gonna tear a hole in this one if I don't worry about it. Okay, so it's a piece you can screw on. It's very important, and I did some testing and I was like, wow, these 3D printed masks leak if you don't print them right, and they look solid when they're really not. So I put one layer of a silicone seal, and these are printed. When you're making the mask, all you're doing is, when you have excess silicone after doing the big mold, you put the extra silicone in one of these molds, and then you make yourself some O-rings. Okay, so I put one O-ring in, then you put your filter in, and that's the nice thing, is you can use any filters you want or as many layers as you want. So we put another mask in, we put the filter media in. This is stuff from Sailrite, and they sell you, a yard of it, and it's FDA whatever for being N95 removal rate. It's very also important that you include this ring. So you put in one of these O-rings, then you put the filter material on top, then you put another filter O-ring, or put another silicone O-ring above that, so it's sandwiched. So the media is sandwiched, the filter media is sandwiched between these two silicone seals. But you need to put this piece in, because when you tighten it down, you want this retainer ring to turn, and it's going to grind and do stuff to this sacrificial ring that will take the abuse. Because if you don't leave it in, it's going to grab onto the seal and it's going to twist it around. It's going to tear up the filter media. So you take this piece, just wind it in, and then use this wrench, and you tighten it down, and that's it. This piece is just an extra for protection. You can use it or not. And then you've got a filter piece, right? So this whole thing, add the straps, and it's nice and airtight, trust me. As far as, it only passes through the filter, but do your own tests anyway. So don't trust me. So that's what happens. And then the thing is, it's screwed in from the back. Let me show you. You can actually hand undo it. There's a flange tube that comes in the back, and I just put the thread and push it up after I've cut that hole in. And I left that solid so you could cut a hole, so you could make your own parts to fit these masks. Now, one of the things you can do, so instead of hooking this piece on, we're going to hook this piece on. I'll tell you about that. Okay, so that goes on, but I have another little wrench, and it comes around, and it tightens in from the back. Now I want it to be turned around completely, so I'm going to loosen it until I get it to the right spot. So I'm going to have it face down. And why is it not working? Okay. So that's sandwiched in there, and the nice thing is you don't need any seals, because silicone is the seal. So it's really beautiful that it both works as the structure of the mask, and it works as the seal between these plastic parts. So this is another way of using a different filter media. And what I've done is these are antiviral filters. This is what the EMTs and the emergency people use when they're rushing someone to the hospital and they have something contagious. They put this on the bag, that bag they squeeze to inflate the lungs and respirate the person until ventilate the person until they get them to the hospital. And this is to protect the EMTs and the person from getting any viral contamination. So now, one of the things that I need to do, I'm going to look real quick and see if I found it. I don't think I found it. I'll look in a bit. But what's missing here is a little, I made a little seal that goes in here, and it sandwiches between here, so it's airtight. I can't find it right now. I'll have to look for it. But trust me, there's a mold that I have for making a little perfect seal that fits these two, and it works really well. Then I designed it so it would simply use like a hair tie, and it goes over. Oh, got a piece. And this part's kind of important. You'd be surprised why you need it, but let's put this on. Okay. So that holds this whole thing on the mask. So if you had access to these filters, which are medical grade protection for PPE, you're good. Because, you know, as long as you don't forget that seal that I can't find any use. So so then what's next? Okay, this part is designed. I didn't realize I needed this part until later, because when this has a perfect seal, you're wearing it on your face, and you do this, you can accidentally touch your chest, and all of a sudden you're like, I can't breathe. The seal is instant. So I know how good the seal is on these silicone masks and stuff. So but the thing is this, like I said, it's about coming up with a solution. I forget how this goes. Basically using this mask design to make it modular and do whatever you want. The thing that you could do if you wanted to, if you didn't like this design, or you didn't like the filter design, the filter that goes in here, and you didn't like this design, let's say it was too heavy or it's cumbersome, it looked silly, and you know weren't going to walk around with a gas mask look on your face, what you could do is make a different design where you have a hose coming off of this, and it goes down to a filter that you wear on your belt. You could either have it pressurized like a papper, or you could just, the thing that you could do is sometimes filters are a little hard to breathe to because there's not much surface area, and all the air has to pass through these restrictive passages and pores. So what you can do is you can design a bigger filter that you wear on your belt or something that's much larger, and it's a hell of a lot easier to breathe. And it's just a hose that comes down, and you get to breathe out of that hose. So there's a lot of different ways that you can take this design and just create your own. You can even create your own mask if it doesn't fit your face. You could design something else. But it's a fantastic way to really, and I wanted to get tested. If somebody knows who can test these masks for their filtration abilities, I'd be glad to submit one for testing. We should go into the printing of it a little bit. I'll draw that up on the whiteboard. Hopefully people get that. There's some things I wanted to cover. Let me check my notes, make sure I don't miss anything that let me see. I'm just looking through my notes to make sure I don't leave anything out. I covered that. Okay. Okay. I've already covered that. Do not trust. One of the things is people are grabbing these MERV filters over whole house filters, and I don't trust those, especially the ones that have a little metal, like a grate on it, and then people pull that off, and then they just use the material. I've seen that glue; it rips a bunch of fibers off, and I don't trust that to be safe for anything. So it's up to you, but I don't feel comfortable telling people that they can go buy one of those big whole house filters of a MERV 16 or something, and then rip that metal that's glued onto the fabric off, because it's just tearing holes into the fabric. Oh yeah, this is another important thing. Um, one of the things is that we talked about the sterilization of these masks. There's good news about this design, okay? And that is, well, PLA, you think, oh, if I sterilize it, PLA's, got a low melting point. Well, it does, but if you anneal it, it has one of the highest melting points if you successfully anneal it, and you can still use it, it's still airtight. And something I created just in case, and I don't really even know that I did, but what I created was what I call the puck. And the puck is the thing that allows me to put all these pieces together and kind of make it like one solid piece, so that when you put this together, it doesn't, there's an insert that goes in here. It all becomes basically one solid structure. And so it doesn't warp or do anything. So all you do is you heat up your oven. I put like a little piece of thin plywood in there. So, when you put this in the oven, you're not just plopping it down on some hot metal rails that'll put, grill lines in the bottom of it. So I just put it on a piece of wood. I heat up the oven to 200 degrees Fahrenheit, 100 degrees centigrade. And I just throw it in there. I leave it for 45 minutes or so. And then I just turn the oven off. And whenever it gets cool enough that you can take it out, it should be annealed. And this thing is now, it won't melt or warp. And then what happens is, with these annealed parts, now I haven't annealed this part, so I don't know yet how that'll hold up. And I don't even know if the puck is necessary. It may not be necessary. You may be able to just throw it in the oven and anneal it, and it won't warp it much at all. But at least if you do need it, it will all be basically one solid piece that won't move too much. So yeah, so the beauty of it is, if you're done with this, now you can hand tighten these easily. You really don't need the wrench for this one, but just in case, or you have arthritis or something, you have this wrench with these good grips to help you get this stuff out. But the thing is, you take this piece. I should leave this in here. You take this piece and put it together. I should take this one. It's an extra. Part of the puck. All right. Anyhow, I'm having a hard time with this. Like I said, you can hand tighten, or you can really wrench on it if you get this piece. And why is it not going in? Anyhow, I'm going to deal with it later. But anyhow, even if you don't need it, you can just twist it and it'll get tight enough plenty. Anyhow, point being is that when you're using this and you come home, other than the filter media that you hold in there in between, you can throw this whole thing in the oven and be done. Just throw it in, make sure it's hot enough for long enough, and you're sterile. You've got it all cleaned. You don't have to separate these two and then hand sanitize it with some wipes or anything else, or you're good to go. So so that's a nice feature of this whole thing. It's just to throw it in the oven, heat it up, wait, you're good. I've also obviously included these things to help print the seals for the mold, and there's another one, like I said, that I can't find right now, that seals this piece. Very important that you get that seal in there, by the way. Okay. So, like I said, I made 3 of them. I'm reading through here. There's people I wanted to thank for being helpful, with Cheryl Kunkel and Mike Cisparo of Silicones Inc. They were very supportive and they helped me out, as well as Reynolds Advanced Materials. Had a little issue with Smooth On. They didn't think this would work. And I said, it does work. I've already done it. And they're like, well, it's not skin safe, or it's not thick enough structure, or whatever. And then I watched like a week or 2 later, guess what they're making? A silicone mask that's made with the structure. I was like, and the thing is that their solutions all require like buying 2 gallons of their materials that are, you know, are not cheap. And then there's a bunch of other materials that are built in. So it becomes very prohibitive for people to start making these and helping other people. The other thing I'd like to say is, you know, when you go and you make these molds to make these masks, you go and you make them and you make as many for the people that you need to make them for. And then there should be a dialogue with people that goes, I'm done with this. I've made all the masks I need. Who needs it? And you can hand it to somebody who wants to take the baton, and we'll set up shop and just start cranking these things out. And again, it's not my particular design. It's using this idea of using this cheap silicone that's fast curing and using it as the mask and the seals and everything else, and go make your own designs. And so, yeah, we made the 3 designs. This is one of my designs. I haven't even cut the flash off. This is another design I really love. This one took some work, and I had to learn a lot in Fusion 360 to get in the sculpting environment to get that sucker worked out. And then there's the National Institute of Health. This is one of theirs they offered up for the world. So what else? Yeah, there we go. I've got that covered. Yeah, one of the things I was proud of is I was able to get this down to basically 3 elements: PLA, the filter media, and the silicone. So not bad, pretty good reduction on it. I mean, I guess you have to add the straps, but that'll be up to you to choose what kind you want to do. The truth of the matter is, you could even, if you had the talent, you could even 3D print a mold for the straps. You know, silicone's been used in scuba masks, so you know it's great for being airtight because it's waterproof and airtight and stuff like that. But you could also 3D print a mold where you just lay out straps if you were short, if the world ran out of elastic like it did again. And then you can custom make your own mask. You can make one that's like a respirator that goes around the top of your head and the bottom. The other thing is there's breaking taps, and somebody else. I want to give them credit, but I can't remember his name now. They had one of the things that they can now do, which is, if they use this technique, because they spent a lot of money and a lot of time getting this stuff done, is they wanted to make a real respirator seal where it has like a flap that's folded in and that really fits to your face. And that can now be done with this technique. It's fast and cheap, and it'll work. And a lot of people tried working with those guys like Breaking Taps, tried to do it, and they bought the wrong durometer stuff. And it was too flimsy and weak and floppy. And you have to find out that there are certain viscosities for pouring stuff, and then there's certain durometers. And you need a higher durometer so that it's not like this squishy, soft stuff that just is really flimsy. And you can always change that. All you have to do is buy a different durometer from whoever you get your silicone from. But like I said, you can run to Home Depot and get this stuff. So, you know, if I need some, I don't need a special order. I have to go research it anymore. I just go buy a tube. Let me find a tube and show you. This is the tube that I use. And these are, you know, if you buy them retail, they're not the cheapest. It's like $5.50 or something like that. But, you know, it's dirt cheap to get a mask that you can use over and over and over again. You don't have to throw out. And you buy some of the filter media that's sold by the yard, and you'll have a very long supply of filter media that you can use. And you won't run out anytime soon or go broke. So yeah, this is GE all-purpose silicone, 100% waterproof, clear silicone 1. There's an asterisk next to it. I can give you the barcode off of this if it helps. And I'll go end to end. There's even those extra numbers. It's 077 027 000 122. So maybe that'll help you find this stuff. Yeah, so that's great. Let me check my stuff and see if there's anything else I left out. Yeah, so all you need is the tools you only need are like a mixing bowl, a little jug of dishwashing soap, and hopefully you've seen the video that I did before. And that's about it. There's probably stuff I'm gonna facepalm myself a little bit for forgetting to mention something in this. But I think that covers most of it. I just, if nobody prints this stuff and nobody goes and makes these masks, that's fine. What I want people to do is just take the idea and go design their own molds for their own masks. And we can get a lot of people covered and protected. Right now, we're back into a resurge of Corona coming back. And people might think it's crazy and, the numbers are starting to rise. But what people maybe don't know, is that when you're wearing these masks, you're keeping these, the numbers may be rising and adding up, but they're not exploding exponentially like they did in the Spanish flu, because everyone else is taking care to protect themselves and other people. So everyone's doing their part. And even though these numbers might be growing, they're not exploding. And that's us making these efforts to take these precautions makes a big difference. And I'd like to ask everybody who's walking around, even if you never use these masks, you need to cover your nose. The air comes out of your lungs, and that's how people get infected. It's not because it comes out of your mouth, it's because it comes out of your lungs. And if it comes out of your nose, it's just as deadly. So please be responsible. It's uncomfortable, but everyone else is taking the hit. They're covering their nose. It's not fun. It's not easy. It's a nuisance, everything else, but you really need to keep your nose covered. So, do everyone else a favor, even if you're not the one at risk, help others. That's what I have to say. If you have any questions, you can leave a comment below, and I'll add anything in the description that I forget and I forgot to mention, because there's plenty of things I forgot to thank some of the other people that helped and stuff like that. Anyhow, I really appreciate you taking the time to watch this video, and I hope you go out there and make masks for people that need them. And I appreciate everything that anyone can do to help in this situation. Thank you. Okay, I went and took a break and found the rest of the pieces of this puck. Pretty simple. Let me show you how they go together. Okay, so here's the main part of the housing for the filter, and then I put this piece on it to support the bottom so it wouldn't drop or droop or anything like that. Then this is the piece that goes on the inside of the mask, and it kind of screws in and sandwiches these pieces together. So again, they're all kind of tightly configured. Then here's an internal structure that you just screw it, and it kind of has this pointed out part, so it fits down in here again, so everything just kind of fits up. Put this disc in, and then throw this part in. And you don't have to screw this tight. You don't even want it tight, because if you heat it up and this loosens under pressure, it might deform it. You just kind of throw it in loosely. Then you put this piece in. And just for extra measure, I put this piece in the bottom to keep this from flopping down or doing anything weird. And it makes one puck that's pretty much solid. So when you heat it up to anneal it, it holds its shape. I did it, so it works well. The other thing is I went and I found the mold that I make for this piece that's missing. It fits in here, okay? Fits in that hole. And so that's how it comes out. And there's your little silicone piece. I'm gonna cut it real quick. All I do is draw a nice semi-straight line from edge to edge. And this is tapered, so that, careful with that, because I could have just cut myself there. This should only be done by an adult. Okay, and what I also want to do is cut this part of the tip off, which doesn't have to be as precise, because I can just use the plastic end as a guide. So Okay, so those pieces should be pretty well severed. Let's see. Yeah. So I'm just tearing it off after I made that little cut. Make some more cuts here. And it kind of doesn't have to be as perfect. I mean, the mask doesn't have to be perfect because of the way I flanged it so that the part that actually touches your face isn't the piece that you cut. So there's your insert. You just pull this piece off, and now you have a tapered piece of silicone. And then all you do is just put it in, put it on your piece like that. So it gets wider as it goes to the bottom, and that's what seals it up. And let's push it in. Let's see. Oh, I think I have to use the smaller end. Yep. So use the narrower port. There you go, and that fits perfect. And then, of course, the hair tie, which is maybe the only part that if you decide to use this is maybe not easily sterilizable. And that just holds it in. So anyways, that's how you get your little seal. This seal doesn't matter because it hasn't passed through the filter yet. Okay, now let's get to one of the things that's important. I thought this thing was all gangbusters and airtight, and I decided to double check and make sure it was. And I found out if you didn't print it right, it definitely wasn't airtight. And the way I can do it, I mean, here's I can show you. And here's some different different colors for all these masks and color code them, putting pigments in them or something. But one of the ways I could test it was to just, and it was airtight. And it just sit there, and that's how I knew it was airtight. But when I stuck it on my face and I held my breath, it wouldn't stay on, and it started easily, slowly letting go. And the thing is, I knew it wasn't perfectly airtight. Now, even if they're not perfectly airtight, what the air really needs to be is the easiest way to get in through the mask is through the filter. So, but it's even better it's even better if it can't at all get past the seals in the sides of the mask or through the plastic, which I was having this problem with at all. So you take this part, and these are the two parts that only really matter as far as the air tightness, as far as the plastic, because there's a rubber seal in here. And let me draw out what I mean. So we're going to do a cross section as if we took a saw and cut this in half so that we can see up in here, and I can illustrate something here. Okay, so this is that gray piece, right? Go like this, right? It's cut in half. Okay, so here it is, and then here's the thread, right? And then we got this. Okay, so the thing is, oh, and here's the little piece that goes on the inside of the mask that goes up in there. So it's like, and it's got its little seal. Okay, and it's got a hole in the middle. Right? So the thing is this, none of this stuff matters. Okay, let's also draw a cross section of the seals. Okay, so the seal would be here, and then it goes around back, and then you have your filter layer that's squeezed between these two seals. Okay. And the thing is, it doesn't matter if this leaks. It doesn't matter if this leaks. The only time it starts to matter is when it gets down to here. As long as it's basically solid from here on out, everything's fine. because it doesn't matter if it leaks all up in here and it's not printed the most thickest, most infill, anything. It just needs to start here, because if it can't pass through here, if it leaks up here, or these threads are really leaky, it doesn't really matter. As long as when it gets to this bottom, it can't pass the air through. So all you need is this part to be printed solid, and basically up to here. And then this seal will hold against this, so the air can't come in by these threads or by porous parts of the plastic. The seal should squeeze down and sandwich the filter media, and then it can only pass through here. Now, and even if it got to this threaded insert, it's still got to pass through the filter to get into this threaded flange tube. So the only part you really need to print solid is all the way up to here. Now, it doesn't hurt. It doesn't hurt to print it, airtight and solid all the way to the top and the bottom. And but it makes it heavier and thicker and takes more time to print. But all these other pieces, this piece doesn't need to be airtight. And even this one, it just has to be these seals that go between need to be airtight. So air can't sneak in here. It's got to be a tight seal. It doesn't matter if it's leaky here, as long as it's so airtight, the pressure between this seal, this filter media, and this seal, then the air won't be able to get through. It has to come in through the filter media, through the flange tube, and into the face. So it's just it's not for everybody. All you have to do is just print the whole thing solid, and you'll get it. You'll be safe. But if you want to print for speed, or save for plastic, for weight, you can just print it solid up to here, and you should be good. The other thing is I put in testing stuff. So one of the things that I did to help me figure this out was I printed this little disc so that it can go on top of the filter media and everything else, and sandwich it in there, okay? And then I could put this silicone thing over and see if it would go airtight. If it went airtight, then I knew that this whole housing was airtight. If it couldn't pass, if the suction was maintained with this hole here. Anyhow, it's very important that your printer's different than mine, your materials, everything else. Sometimes the nozzle gets clogged a little. It's always very important that you test that this is airtight, because like I said, I thought my previous prints for these housings were airtight, and they absolutely were not. So just make sure that when you do all this stuff, that when you suck the mask on your face, if you hold your breath for a little bit, if you feel it easing off, then this probably not airtight. So don't worry, so just check that out and make sure that it's a good fit. So I hope this helps too. And if you have any questions, I'm sure there's a lot of questions. I took months to figure this out, to get these designs perfected, and everything to fit right and size right and everything else. So I know it's not easy, and there's got to be tons more that I've left out. So just ask away, and I'll do my best to help everybody with any answers, give them the answers that they need. Thanks.